Mathematics is considered the tool for solving problems because in a problem, there could be a lot of solutions. And with that, we should get the most concrete answer or the solution and maybe the fastest as possible for us to have a rich output and a good orientation of solutions.
Diba, Ian discussed about how mathematics can be used as a tool for solving problems efficiently, right? Allow me to now give my views on the topics under this branch of mathematics. I think that it's important for one to familiarize themselves with linear programming and transportation problems, especially if one later on will find himself having to work or handle business in the future. Businesses kasi, they make use of these branches of mathematics to determine the best methods of increasing profits and also decreasing operational costs. To be more specific, linear programming in particular enables businesses to find solutions that they want for their operational problems, identify issues that might change their desired outcome, and find an answer that gives the result that they're looking for. As for transportation problems, businesses make use of this when they need to decide how they will transfer goods from several sending locations to several receiving locations with minimal costs or maximum profit. It also makes use of the laws of supply and demand in economics, which I'm sure you guys are all familiar with, in which the supply of goods coming from the regions must satisfy the demands of each destination point, with no remainders or overload in supply for demands whatsoever. Yes. Let's move on to mathematics in natural sciences and in the arts. Yay! If you guys remember your calculus classes back in high school, you may have come across or heard of the term Fibonacci sequence. What is the Fibonacci sequence? Basically, it's just a series of numbers in which each number is a sum of two preceding numbers. Let me give you a visual to demonstrate. So we have the Fibonacci sequence here. For example, let's look at the numbers here. We have 0, 1, 1, 2, 3, 5, 8, and so forth. If you add the first two numbers, 0 and 1 here, together, you'll notice that it will give you the next number in the sequence, which is 1. And the same goes for 1 and 1, 1, 2, 2, 3, and so forth. Also, if you look at the sequence further, realize that if you take any of the two successive Fibonacci numbers, one after the other, the ratio is actually very close to the value 1.618. And what's so special about 1.618? Well, this special number is otherwise known as the golden ratio, which in the Greek alphabet is denoted by the letter phi. Yes. But you may be wondering, how the heck does the Fibonacci sequence and the golden ratio relate to natural sciences and the arts? Oh, well, whether you know it or not, there's actually a strong connection between the Fibonacci sequence and with the composition of artwork. Um, hmm. Let's say that each Fibonacci number is a square, for example, increasing in size in the same way that the sequence does. Then, after connecting the opposite corners of each of the squares, you'll create what is called a Fibonacci spiral. And this spiral makes use of an aesthetically pleasing principle called the rule of thirds, which is often used by artists in balancing the features of their artwork. Examples of such artworks that make use of these spiral proportions is Da Vinci's Mona Lisa portrait painting, which I'm sure you guys all know, yes, are in the formation of the pyramids of Giza found in Egypt, yes. As for the golden ratio, on the other hand, this value is employed in nature science through, for example, the arrangement of flower petals, the branches of trees, reproduction of bees, the structure of DNA and the human body, also the distances in spiral galaxies, and even in like the movement of air and wind in hurricanes. Mean to say, these mathematical concepts, I guess, the Fibonacci and the golden ratio, are very much present in our everyday lives. And now we will go on to fractals, which will be further explained by Raphael. Back to you now.
Okay, so for this video blog, I will be talking about fractals, what they are, why we need them, and why is it important to learn about or understand it. So first and foremost, it's a field in mathematics that deals with symmetry, balance. So essentially, it deals with how symmetrical something can be, how balanced it will look, everything. So that is what fractals. That's the base of what fractals of what they are about. With regards to its uses, the easiest way to look at to see the application of fractals is in architecture. For example, a building or a house. You can understand as to why a certain facade looks that way. It can be in an artistic sense or it can be in a practice to make it stand or to attract. It can go either way or it can go both ways, not mutually exclusive. Now, for that reason, we can understand if we want to understand why buildings or houses are designed in the way that they are designed, and as to why floor plans are designed the way they are designed as well, is to understand fractals, to learn about it, even the most basic. And the aforementioned reasons are as to why think, I believe that they are most important to learn for anybody, especially enthusiasts and architectural enthusiasts.